I do have a few questions we need to go over. There is one thing I need to clarify, and then I have a 3x5 that I will show you. So what I did, we're all still good, right? We all hear me? Hello?
Yes.
Okay. All right. So one thing I do need to clarify from the other day was when I showed you this, okay? So right down here, when we talked about this, there's two different places they talk about Cl2, okay? And there's two different applications. So I'm talking about, see how I've written this in red right here, okay? What they've got is, and you can actually find this in the text, but something I feel like I've got to point out because there's a question like this on the test. And is whoever I was talking about this after class with on here? Who was I talking about this with? Was it Sierra? Is Sierra on here? Wasn't Sierra? Or she's not on here? Okay, so what happens is this. When they do, okay, and this is, let me just get started here. It is 4:27, and this is going to be Chem 11:10. Cumulative review, and we're gonna go, what did I say, 5 days, 4 days, something like that. Okay, and we're just gonna call this day 1, and this is 4/27 of 2020. Now, halogenation. Okay, halogenation. Now the problem is that what I'm going to show you right now only applies to Cl2, okay? And they do this two different ways. And what happens is if it is just a regular alkane. So if I had this, so this would be what? Ethene, right? Ethene. And I add Cl2 to that, right? Now, what's going to happen is remember, when it's like this, it is really Cl bonded to Cl, right? This bond is going to break, okay? That bond's going to break, and they're going to bond here. One of these Cl's is going to go there. The other Cl is going to go right there, okay? And this is no catalyst. Okay? Now, that is different than if this is an aromatic now. Now, if I have this plus Cl2, okay, and let me, while I got that, this part right here, this is on page 470. Okay, this is different. Even though they're double bonded, this is now an aromatic and not just a ene. Okay, not just an ene. When it's an aromatic, okay, and they take an aromatic and they add Cl2 to it. Okay, now this is what happens. I take an aromatic and I add Cl2 to it, it does this. So pay attention to this because this is important. There's probably a reason I'm discussing this if you get my drift. Okay, this again is going to be Cl bonded to Cl, right? Here, each one of these still has one H on it, right? They still have one H on it. Okay, what will happen is that this requires a catalyst. This requires FeCl3. An aromatic, so basically benzene plus Cl2. And this is the only one this works with. Okay? I'm going to take this, it's going to break. Okay? One of them is going to replace that H. That H is going to replace it. And I will end up with this. That's what you're going to get. Okay? Now there's obviously a reason I am discussing this right here. If someone gets my drift. Is there a reason no one's talking to me? Because I can't hear anything from anybody. It's like I'm all by myself. I need someone to respond.
That is great, Mr. Denton.
Okay, thank you. Appreciate that. Does that make sense?
Yes. Yes.
Okay, and hopefully we understand why I'm discussing that. This is on page 486. And they're different. Very similar though, but different. Alright, so we're good there. Aaron Haas. You there, Aaron?
Yeah, I am.
Okay, so questions. You had a couple of questions, right?
Yeah, I did.
You want to look at them?
Yeah, let's pull it up. Okay, yeah, do you have that enough too, or?
Just 1 second.
Hey, Denton.
Yeah.
Sorry, I just joined in. Did you talk about the FeCl thing that you wanted me to remind you about?
Huh. Did I talk about that, guys?
No, not at all.
That was not very nice, but yes, yeah, we took care of that. If you have any questions on that, it is on the first 5 minutes of this video, Sierra.
Okay.
Alrighty, so Aaron. Alrighty, so this is what I've got. So you guys, I don't know if I can turn this or not. So Aaron, was this one of your questions?
Yeah, what?
Okay, so did this have, so that's the question I just answered, correct?
Yeah.
So I'm going to guess it's just 1 Cl, doesn't matter where you put it.
Okay.
That's pretty much word for word, right? I mean, granted, this is different, but I still got a benzene ring, adding Cl2, and FeCl3, right?
Yeah.
That's funny. Just a minute, my wife's calling me. Yeah. I don't know, you called me this morning. Oh, okay. Yeah, I don't know. Okay, well, I'm teaching. Love you, bye. Alrighty, so what do we got next? So that was that one. Here comes the next one.
Was that Christy with an IE?
Yes, that was. She's the best. Alrighty, so Aaron, was it?
Yeah, this one is only B.
Only B. Okay, so cinnamaldehyde. Yuri, was that you?
What?
Okay, wasn't this one of your questions we talked through as well?
Oh yeah, this was one to me. Oh, yeah.
Okay, how did we fix it? Do you remember?
The double bond and the...
Oh, so what happens here, Aaron, is this C, Yeah, to be an aldehyde, there's got to be a double bond right there. Because if you go back to last chapter, aldehydes had C double bonds to O.
Okay.
Does that make sense there?
Yeah, it does.
Okay.
There have to be lone pairs on the O.
I think it said not to put lone pairs on that one.
Okay. Let's see. Yeah, do not include lone pairs. Okay, so there's that one. Here's the next one. Given the structure corresponding to 1,3 heptadiene, or is it the next one? Okay, so.
I see what I did wrong on the first one. That was pretty obvious, but, yeah, B at least.
Okay, so what you guys need to understand is that when I draw something cis, okay, and this is like funny because I just did this for somebody else. But when you draw these, and a lot of this is the fact that of the way you draw it. So if I go back and I draw yours, it looks like this, right? Now I want you to, I'm going to twist this a little bit. I'm going to draw the exact same thing, just tweaked a little bit. Okay, here's my double bond, right? Now if I look at this, that'd be an H, that'd be an H, right? These are the exact same molecule. Okay, but because I've twisted this flat now, this one's down here, that one's up there. What is that? Trans. You see what I'm saying?
Yeah.
So to make this cis, instead of that branch going here, that branch has to come down here. And do you see how I just twisted it that little bit? Changes the way you look at that double bond?
Yeah, so if you're drawing it, like, on the homework, would you have to, like, draw in the H's for it to...
I don't think so. I don't think so. All you'd have to do is do this. So if I went here, I would have just went here, here, here. Something like that. Now I'm cis because now that's an H and that's an H.
Okay, that makes sense.
Okay? Gauge.
Here's the thing. I don't get it.
Isn't this very similar to the one we did?
This is the exact one we did, yeah.
So what don't you get?
I just don't get cis and trans.
So,
It looks the exact same thing.
okay, but it doesn't. It isn't, because now these two are basically coming off the same side. These are both going down. Whereas up here, this one's going down and that one is going up. And because of the way they bend like that, and this isn't twistable, it kind of clusters things up. Does that make sense?
Yeah.
And because this side gets kind of clustered, it changes the way it reacts. So this and this, even though they're almost identical, they're not the exact same. This is trans, this is cis, and they would behave slightly different. Does that make more sense?
Yeah, I think.
Okay. And the last one, here's the last one from Aaron.
Yeah, so I got this one right, but I don't understand why you have to put the H with the SO3.
Because if you don't, it's not happy. You would have a lone electron there.
Okay.
Because sulfate would have been SO4, right? But that's 2 negative. SO3 is still 2 negative. I would use one to bond. The other negative would have to be occupied by that H. That's why.
Okay.
If you drew it out in like a Lewis structure, you would understand that there would be no way to make that happy without having that H there. You'd have one lone electron left over.
Okay. Yeah. Thank you.
Yep. Okay. Anybody else? That actually worked out pretty good. Okay.
Mr. Denton,
Yeah.
what are the homeworks due?
You know, it's relative. I've been asked that a couple of times. I don't know. Well, I mean, here's the thing. Was that you, Allison?
Yeah.
I really don't care. As long as they're done before the end of the year.
Okay.
You know what I mean? My only concern is, you know, right now we're going to start on our cumulative review. And I'll just show you what I did. Okay, I literally took and broke down, I broke the next 60 questions down into 15 question increments. And I figured I could do those 15 questions in 4 days, you know, 15 a day. 4 days would give us 60 questions. And then that'd give us, I think, 1 day, right? Won't that give us 1 extra day? So let's look. So I got 1, 2, 3, 4, 5, 6. Oh, hell, we got all kinds of time, right? Because we're taking the test on the 15th. So we have 1, 2, 3, 4, 5, 6. We have 8 days left. Okay? Now, I don't know. So it's one of those things that I would get it done just so it's not hanging over your head. And then that way you can focus more on the review. Does that make sense?
Yeah.
Is Emma on here? No Emma?
Yeah, I'm on.
Okay, what date did I tell you?
I think, hold on, let me do that.
Did I put a date on then?
Yeah, you said you have them being due May 13th.
Okay, so that was the last possible time you can turn them in, Allison.
I don't think I'll like that one.
Well, I wouldn't either, but I'm just saying. Okay? Alright, so here we go. We're gonna, here's my 3x5. We're gonna talk about everything that's on here. I figured I could devote 3 minutes per topic I have. Most of them won't need that much, but we'll just see what happens. Okay? Alrighty, so, first thing I have written down is scientific notation. Do we all remember how to do scientific notation? Any questions on scientific notation?
We just do one.
Yeah. So if I gave you this, and I wanted you to write that into scientific notation, okay? Anybody want to take a stab at that? Nobody?
Oh, go ahead.
3.7.
Is it?
3.7.
Or is it that?
You remember the first 3 with scientific notation?
Yeah, I did 3.72.
Okay, how many sig figs does that number have in it?
Six.
How many sig figs should that have in it? You see what I'm saying?
Oh, I hate big figs.
Yeah, that's the answer. But it is 10 to the 8 because I went 1, 2, 3, 4, 5, 6, 7, 8. But that has 6 sig figs. That's got to have 6 sig figs in it. Okay? What?
Wouldn't it be to the 3rd instead of the 8th?
No. If I went to the 3rd, I would have stopped there. My decimal's right there. I still moved my decimal 8 spots. I just have to keep all those numbers because they're all significant. That makes sense?
Wait, how do you know how many aces is in the decimal?
Yeah, well, your decimal can only have one number in front of it, so that's always the same. But then decimal places I've got it. They just got to match. This has 6 sig figs. This must have 6 sig figs. They must be the same. Okay? All right, density. Who remembers what density is? Mass divided by volume, right? Mass over volume. Okay? So if I have so let's say I have a volume equal to, I don't know, let's say 42.6 milliliters, and a mass equal to 0.76 grams. What is my density in grams per liter? Anybody know how to do that? That was a question. I didn't want the silent treatment. Nobody?
So, yeah, but the 0.76 over the top.
So I got 0.76 grams. Say it again, Tillman.
And then on the bottom, do 42.6 milliliters. And you have to switch that to actual liters, so you have to divide by 1,000.
So 0.76 grams over 42.6 milliliters. Can I just times that by 1,000? Or I mean, yeah, 1. Now how do I want to do that though? Well, but if I wanted to do like dimensional analysis, you know what I'm saying? Can I do it that way?
Yeah, it'd be 1,000 milliliters over 1 liter.
1,000 milliliters over 1 liter, like that?
Yeah.
So my milliliters would go away, wouldn't it?
Yep.
And then that times that divided by that, because that would have been grams per milliliter. Grams per liter is going to be a lot bigger, right? So what do I get here?
That is 17.84. Yeah.
17.84?
Except you would just do it to 18.
Just 18? That'd be grams per liter. It'd be 18 grams per liter. Why?
Because of sig figs.
Yeah, that has 2 sig figs. That has 2 sig figs, right?
Yep.
Okay. Alrighty, so let's say that I have copper 12 and I have copper 14. These are my 2 isotopes of copper, right? They're the 2 most common. This is what I use to do what? Anybody know what copper? I don't know why I said copper. I meant what? What's it supposed to be? Anybody know?
Carbon.
Carbon, thank you. Carbon 12 and carbon 14. Okay, these are my 2 isotopes of carbon, right? How would I write that as an isotopic symbol? Anybody remember? Not a soul?
With the C in the center, and then your 12 at the top left, and then your atomic number, or your mass number there.
Now that is my mass number. This is going to be a 6, right? and then carbon 14's like that. Correct? These are my isotopes, right? Now, carbon's actual mass is 12.011 grams. What does that tell you about those two isotopes?
The 12 isotope is much more common.
Carbon 12 is much more common. Okay, and what I realized just now is that the question that is on the test that's based on this is the exact question that was on the test when we gave this test. I just realized that. Okay? Alrighty. What if I did this? What if I said fluorine and I said 9 and 18? What would you tell me about that one? Nobody?
The 9's supposed to be on the bottom.
Yeah, but this, if I wrote it this way, what would you say?
That's wrong.
Yeah, this is not possible. Not possible. Okay? Alrighty, so ionic compounds. Okay, now, if you go back, now granted this has been quite a while ago we did this, but if I was going to take an ionic compound, let's say I wanted to take a compound between, let's say I wanted to go with let's say I wanted to make calcium, let's say I want to bond calcium and nitrogen. Okay? Now, based on what I know about calcium, what does calcium always want to be? Anybody got a periodic table in front of them? Nobody?
I do.
What does calcium always want to be charge-wise?
Is it 2 positive?
It's a 2 positive, right? You're right. It's a 2 positive, so it'll look like argon. Whoever said that, exactly right. And I'm going to add that to nitrogen. What does nitrogen want to be? 3 negative, right? Who can remember how I got them together? How'd we do this?
Don't you like switch their charges?
Yeah, didn't we just do that? Did the old drop and swap?
I was going to answer that.
I had Ca3N2, right? Anybody know what you would call that? How would I name that? Been a long time ago.
Are you asking for like tricalcium dinitrogen or like?
I don't know. Would I name it that way? Would I name it using those Latin prefixes? No. You only named covalent compounds using Latin prefixes. We learned 2 different ways to do this. One was with Roman numerals, one was without. Is this a Roman numeral one? Anybody remember what specified that? What?
Is it like calcium 3 nitride or something like that?
Nope. It is just
Roman numerals are ones that have isotopes.
calcium nitride. Roman numerals is when it was a what? It wasn't isotopes, but it's
Transitional metal.
a transition metal, meaning it had what? Tolman, what did that mean?
It means that they can have different amount of bonds.
Yeah, but what do we call that? It meant they had more than one what? Anybody remember?
More than one valence?
Kind of, but that's not the word we used.
What was my charge?
Yeah, but there was a word there we used. It was more than one. Starts with an O.
Oxidation state?
More than one oxidation state, exactly. Calcium is a representative metal, which means it only has one oxidation state. It doesn't need a Roman numeral. Okay? Now, let's say I wanted to do, let's say I wanted to put strontium with sulfate. Let's say I wanted to put strontium and sulfate together. What's strontium going to be?
Two positive.
So I got SR2 positive. What's sulfate going to be? It's going to be what? But what is it?
SO4 2 negative.
SO4 2 negative? Because remember, it's one of those what? Pentatonics. I hope you have that chart still. That'll come in handy. Right? How would I get that together then? Would I do this? Would I get that?
No, you would simplify.
I would simplify it and it would just be SO4 would be my answer. Okay? Alrighty. Electronegativity. Okay, electronegativity. Anybody remember what electronegativity was? Anybody?
The top right is the center.
Say that again?
Top right is the reactor.
This is the highest. Exactly.
It's like the amount of pull the electrons have on the... Yeah.
How much the atom wants the electrons. Okay, we talked about this. Fluorine was the what? Who remembers what fluorine was? Anybody?
4.0.
Yeah, but you're right, but what do they call fluorine? Cheesy video.
Most electronegative
Yeah, but
element.
it was the what of the the 2-rex of the periodic table, right? So it's the highest, which means this one down here was the lowest, right? And so we just compared, right? So if I said which one, if I gave you a list of elements, like let's say I gave you this. Let's say I gave you silicon and bromine and barium and potassium. Let's say I gave you those 4. And I said, which has the lowest electronegativity? What would you tell me? Potassium's the lowest?
I'd say BA. Barium is the lowest.
I would say barium. Why?
It's the closest to that bottom left.
It's the closest to the bottom left. It's closer to francium than potassium is, isn't it? Right? Does that make sense or no?
Yes.
Okay? Okay? Alrighty, so something like that. What if I gave you this? What if I gave you... What if I gave you diphosphorus pentasulfide? What would be its formula?
P2S5.
P2S5? I just about wrote 5 out there for some reason. P2S5? Anybody got something different there? Anybody agree?
Sure, why not?
Sure, why not? Yeah, just like that. Okay. Alrighty. Valence. Anybody remember what valence was? Outermost electrons. Outermost electrons. Okay, so what if I asked you this? What if I said, how many valence electrons does sulfur have? Anybody remember how we figured that out?
The column number on the very last table.
Yeah, the group it's in, right? Well, what group is sulfur in? When we say that, we're talking about what kind of group. We had 2 kinds of groups here. And remember what kind of group number that was? Because what's the highest that number can go to?
8.
It can only go to 8, right? So which groups did we talk about here? And remember what we called them?
Main group.
Main group elements, right? They were the main group, those 8, right? Well, what group is sulfur in?
6.
Sulfur's in group 6, so it must have a valence of 6, right? Now, if they ever ask you about like something like this, CO3 2 negative. Okay, this is what? Anybody remember what CO3 2 negative was? Nope.
Carbonate.
Carbonate. Remember how I had you? Well, let me put it this way. Remember how I suggested at some time in the past that you guys memorize like 6 of these? Maybe there was 7 of these. Was there 8 of them? Anybody remember how many I told you to memorize?
Remember that time you said that and none of us did it, and then you kept telling us that we should memorize them and did?
Yeah, and then somebody tried to make a stupid meme of things I say a lot. Huh, I wonder who that was.
Not me.
Yeah, my ass. Okay? Carbonate's one of those polyatomic ions I told you to memorize. Okay? If they ask you about a polyatomic ion, no matter which one it is, okay, and I told you to memorize like carbonate, and nitrate, and phosphate, and sulfate, and hydroxide, and then there was one positive one. Does anybody remember the only positive polyatomic ion I told you to memorize? Did we ever even... What? I didn't hear you.
Ammonium.
Ammonium, right? Well, if they give you any of those polyatomics and they ask you about its valence, anybody want to guess what its valence is always going to be?
It's charged?
No, just its valence. How many valence electrons do all those polyatomic ions have? Anybody want to take a guess? No? It's always an 8. It's 8. Okay? It's an 8.
That's the valence for all polyatomics?
Well, yeah, that's what I'm going to teach it. There are a couple of exceptions, but we're not going to deal with any of them, so it doesn't matter. You know what I'm saying?
Yeah.
Okay. So let's say I take AB, and it breaks up into A plus B. Does anybody remember what kind of reaction that was?
Decomposition.
It's called the decomposition reaction. How many of them did we learn?
Like 4 of them.
Like 4 of them, right? We had what?
There's like single replacement, I think double.
Single replacement, double replacement,
In addition,
And combination.
combination, and decomposition. Those are the 4 main ones, right? So make sure we remember them. Okay? Now, there is a question on the test that I know like 80% of you missed on the test. And it's something like this. It says, which sample contains the greatest number of, and I believe the word they used was particles. No, greatest number of molecules. Okay? Now, and then it's going to give you like 4 of these. And to truly figure this out, you're going to have to go and figure them out, right? But if I gave you like 50.0 grams, correct? And let's say they're all 50 grams. Okay? Anybody know the easiest way to do this problem without doing the whole thing? If they all have the same mass, how am I going to tell which one has the greatest number of molecules?
The one
it'd
with
be the
the,
one with the lowest molar mass.
Yep. Find the lowest molar mass. Because if it's got a very small molar mass in 50 grams, I'm going to have what? I'm going to have a whole bunch of them, correct?
Yeah.
Okay? Alrighty. Next thing I've got is redox. Anybody remember what redox stood for?
oxidation and another one.
Reduction.
Oxidation reduction, right? Anybody remember what I told you here? I taught you a little mnemonic device here.
Oil rig.
Oil rig, right? Oil rig. Oil stood for
Oxidation is velocity. And reduction is gain of electrons.
Is that you, Gabby?
Yeah.
Are you going through your notes?
Yeah.
Nice! No, that's what I want you to do. That's a good job. Anybody else doing what Gabby's doing?
Yeah.
Okay, good job.
Yeah.
Yeah. So what they're going to do is they're going to give you a compound. So let's say I did this. Let's say I did C plus O2 gives you CO2. Okay? Now, whenever it's just like this, it's going to have an oxidation number of what? Anybody remember when it was like this, what its oxidation number was? I'm looking around the room right now, and I'm not seeing any hands. Oh, wait. It's because I can't see you. Say it again. Nobody? Gurney? Tolman? Anybody?
Oh, pull up your periodic table.
Me?
Yeah.
Okay.
It's the, like, you see the 1, -2, -3 on the very top?
Yeah?
It's that.
Close. I mean, in a minute it's going to be that. But as it's written right now, what is it? Tolman! You there?
Wait.
Which one?
You!
What
Me?
was it?
Now over here, but what was it over here? Carbon is what right here? No. It's 4 positive over here, but what is it right here?
4 negative.
Nope. Nope.
0?
What?
Is it 0?
0! Why is it 0? Who said that?
Oh, it's by itself.
Because it's elemental, right? What's O2? No.
Also 0.
Also 0, because these are both elemental. Over here, what's my oxygen?
1 negative.
Negative?
2 negative, right? But I got 2 of them, which gives me a net 4 negative. I have 1 carbon, which meant it had to be a 4 positive, right?
Yep.
So now, what happened to my carbon?
It gained. No, it lost.
It lost, which means my carbon was what?
It was oxidized.
Oxidized, which means by default my oxygen has to be reduced. What else did we learn right there? If it was oxidized, it was my RA, my reducing agent. If it was reduced, it was my oxidizing agent. And it makes sense that oxygen would be the oxidizer, right?
Didn't you show me one example where that wasn't true though?
Yeah, there's probably one out of all the ones we did, but yeah, for right now, just do it. Okay? Just remember, if it's by itself, and it's not got a charge on it, it has an oxidation number of 0. Now, if it started, like if I had, I can't even think of one, I don't know, let's say I had an ion, like if I had Na positive, well, it obviously has an oxidation of what? Yeah, it's a 1 positive. You know what I'm saying? And if there's a negative, then it'd be whatever that negative is. So just kind of remember that. Okay? Catalyst. Anybody remember what a catalyst does?
Speed things up.
How? It does, but how? Is that you, Brecken?
Yeah. What was the activation energy?
It lowers the EA, and that's how it speeds it up, right? It makes it so the hump isn't quite as what? Big, right? Okay? Smaller hill to climb, I think, is how we referred to that, wasn't it?
Yeah.
Did I show you guys the back of this? Here's the back now. We just did that one. So, K equations. So, if I gave you, like, 3A plus 2B yields 4C plus 1D, anybody write a K equation for that? Anybody remember how to do that? It was always products over reactants. Nobody remembers this?
I do, yeah. So it's like 4C plus 1D in like brackets.
Okay, so I got brackets, I got C, I got D. Where do those numbers go?
Oh, they're like exponents.
Exponents. I got a 4 and a 1, and then I would have A, and I would have B, and that would be a 3, and that would be a 2. What would have went in the brackets? Anybody remember what goes in those brackets? Brackets mean what?
Smaller mass.
Nope.
Oh, concentration.
Concentration.
Hey, Dan, I have a question real fast.
Yeah.
On your reaction at the top, are
Yeah.
those arrows supposed to be going both ways?
I don't know what are you saying?
I don't know. I was confused about something, but I'm good now.
Okay. I didn't even have to say, hey, who's at the door? Although someone would jump up and run to their front door and go, how did Mr. Denton... Never mind. Okay? Now, let's say I'm looking at this. Okay, and let's say that I had a liquid, a gas, and a liquid. Here's my equation again. And let's say I increase the pressure. I increase what?
You got it, never mind.
Okay. Let's say I take this equation right here and I squeeze it. I increase the pressure on that situation. Which way is it going to want to go? To the left or to the right? Anybody remember this?
The right.
It's going to want to go this way?
Oh, no, it's the left.
To the left. Who was that?
Myers,
Okay, Myers. Why is it going to go to the left?
because when gas is under pressure, it turns into a liquid.
Exactly, right? So if I pressurize this, it's going to favor the things that take up the least amount of space. And liquids take up infinitely less space than a gas does. Remember how I had my water bottle and we talked all about that?
Yeah, and then that one sub blew up your water bottle.
Yeah, freaking subs. Gosh, man. That makes sense? Or no?
Yeah.
Yep.
Now what if I did this? Let's say I went 2A plus 4B is in equilibrium with 5C plus 1D. No, let's say 4D. Okay. Having trouble writing this morning. 4D, right? And let's say I reduce the pressure. Okay, by reducing the pressure, it's going to give my things more what?
Space.
More space. Which way would this one go? Let's say they're all gases. Let's say they're all gases. I got all 4 gases in here. Now which way is it going to go?
To the right.
Now it's going to go to the right because they can take up, these take up more space than those do because there's 9 here and there's only 6 there if you think about it that way. Right? If I shrunk it, then it would go this way because there's only 6 there and they're going to take up less space, right?
Yep.
Okay. And that's that's the last thing I had to talk about. Equilibrium shifts based on change in pressure. That's everything for today. That takes us from question. Now granted, this is my test. That took me from question 21 to question 35. Next time we'll go 36, and that's about exactly as much time as I wanted to take up. Okay? Anybody got any other questions?
Could you do another readout example?
Yeah. So let's say I did. Let's say I did this. Let's say I went CH4 plus O2 yields CO2 plus H2O. Okay? Now, what do we know about H? What is H going to be 99% of the time? What's its oxidation number going to be?
1 positive.
1 positive, right? There's 4 of them, which means that carbon has to be a what?
4 positive.
Has to be a 4
Negative.
has to be a 4 negative, right? Because that 1 times that 4 made that a 4 positive. That one has to match 4 negative 1. I don't know what the hell that's supposed to be. That's supposed to be a 4 negative, right? What about my O2 here? O2 is elementals with a 0, right? Over here, what's O? It's a...
It'd be 2 negatives, so it'd be 4 negatives.
4 negative, which meant this had to be 4 positive, so it's a 4 positive, right? Oh, here again, the 2 negative. H is a, what did we say H was?
1 positive.
1 positive, right?
So you're 2 positive and 2 negative.
Yep. Oh, yeah, so that 1 positive was up there, so that should have been a 2 positive down there, right? But whatever. No, I don't like that. No matter what, for what we're doing, H is going to be a 1 positive. That makes it look like it changes. So, H did not change. So what does that tell me about my H?
It's a spectator ion.
Yeah, kind of. It's neither. It's not oxidized or reduced. Okay, my carbon goes from a 4 negative to a 4 positive. So what did it do?
It lost electrons.
So it was oxidized. My O went from a 0 to a 2 negative, which means it did what?
Gained electrons.
So it was reduced. Right? So if my carbon was oxidized, that makes it my reducing agent. That makes it my oxidizing agent, thus the term oxidized, because it's oxygen. That makes sense, Allison? I think that was you? Okay.
So on the track, it would just ask, like, what's the oxidized agent, or what's the reduced agent?
Yeah, let me see how they asked the question. Yeah, no, it just says, what's oxidized, what's reduced?
Okay.
That's what the question asks. I mean, it's similar. Obviously, I'm not going to give you the exact question. I've literally just gone through, what I did is I just went through the test, and I just wrote down the topic of the question, and then we're just discussing that. If they give you something like this, obviously that is not the equation they use, but it is similar to that.
Okay.
That make sense?
Yep.
Okay. Anybody else?
Can you show us your 3x5 for chapter 13?
Last ones?
Yeah.
Yeah, this was it. And remember, we just fixed this, right? I just specified that one. Right? So don't screw that up.
What about the backside?
Well, here's the backside. Oh, there is no backside. Because remember, there's only about 20 questions on chapter 13, and then 60 on the other one. Did anybody happen to notice what our highest number got to?
I think that's 67.
Oh, so not bad. Okay. Alrighty. Remember, we're going to go every Monday, Wednesday, Friday from now till the end. I'm going to do what I'm doing today. Finals with 20% of your grade, so I would not miss this, okay?
Okay.
I'm going to leave my camera open for this meetup for the next hour. If you have any questions, feel free to get on, okay?
Okay.
See you guys.
Bye.
Now, Google Apps, that's what it is. Okay, this will access my Google Drive. So I can put it in anything I want here. Let's say I want to do a copy of, I don't even know. Okay, let's just do this. I want to insert this copy. I want to embed this here. I can embed it so it'll show all students, and then when they click on it, it'll basically create a copy. Now, when they, if they want to do it. Like if I did this with a Google Doc, and again, that's more external tools, Google Apps, browse my Google Drive, and then attach any, and then select any Google file, any file there that I want to put in. We're not save that because I'll put that example of that. So that's one way to do it, right? Another way is to just go to the document. So here's, and I think it's really nice to know this. I think it's really nice to know this, to be honest. So I'm going to go to, and that's the ability to force a copy of a document. Mm-hmm. What I'm going to do here is I'm going, here's a brand new Google Doc. Do this or perish in the attempt. That would be one of my, that would probably be the epitome of my assignment instructions. All right. Here. I'm going to name it the same thing. So I'm going to go to share, get shareable link, and then I'm going to copy that. Now that link will look like this, right? Now, it'll be this big ugly thing. Mm-hmm. Now, one thing I can do, a little trickier though, see it, and it's kind of hard to see because the lines return here. I'm going to shrink that down a little bit so you can see it. A little bit more. So, see how it says sharing at the end, edit, /edit, and then question mark USD equals sharing. I'm going to just change that to copy. Now, you'll see that when I put that, into a browser, it's going to ask me to make a copy of that. Anybody who clicks on that link is going to get this message. Do you want to make a copy of this? Now, making a copy of that will make it so that, let me get back to it. We'll make it so that anybody who clicks that will get their own fresh copy of whatever you put out there, and they won't be able to change your original copy at all.
Brian, can I add one to that?
Yeah.
My favorite thing is instead of copy, do template/preview, and then the kids can actually see what it looks like.
Ooh, I'm going to try that. Template, okay, so you did, instead of just put copy, you put template
/preview.
/preview.
So sometimes I give my kids a couple choices of what they're going to do.
Now they're going to say use template. Oh, very tricky. Very nice.
Just a little prettier, and then they get to see what they're getting a copy of.
That's Jenna Augustin. She's one of our ISM now, and she is awesome. Thank you. I'm going to steal that from you and then claim it for my own.
It even works with Google Forms.
So anybody who's listening right now, this was my idea. I came up with it, actually developed this. This was totally not Jen Augustin. So that's interesting. Okay, so instead of, again, let's go back and show what it looked like originally. Now, this is a link, a shared link from a Google Doc. I got this by going to the Google Doc, and then, by going to this Google Doc, and then going to the share button right up here, and then copying the link, right? Now what I've been telling people the whole time is, like I've done, I've been here telling people to change the edit and everything after it to copy. Well, what Jenna is saying, she's come up with a new hotness, which is to put template /preview, excluding that whole template functionality. And by the way, thanks to all of you who sent weird templates in for our domain for Google Docs. I've enjoyed declining them. Now, all right. Then when you enter that, then the student sees what they're getting a copy of. That is so cool. I am going to steal it. And Ryan, now I mean, it's really nice of you to compliment Jen on it, but I think we've already clearly established that this is my idea. Now, and that I came up with that out of whole cloth. So let's be accurate here. All right, now let's do what this looks like in an actual Canvas document, Emma. So I'm going to change this link text, let's do this, to be a link to that, to making a preview of that copy. Now, what I'm going to do is highlight the text. I'm going to click this link to URL button right there. And that's just pretty straightforward. I'm going to paste Jenna's idea there, which is totally mine. Hit insert link, and then I'm going to hit save. Now, when a student clicks on this, now they're going to click on let's do this, and you'll see it'll be kind of formatted that way. Now, that'll come up with, bam, bam, baby. Oh, that's beautiful. I love that. Oh, great job, Jenna. Thank you for sharing that. Hey, I'm so glad you were here today. Now, that is so much smoother, more slick than just a blank, would you like to make a copy? This showed you how to do that. That is so cool. All right. Now, okay. Hey, if you're just joining us, welcome to our WC EdTech News Live. You're with Brian and Alex. Alex, how you doing today, man? Alex? He's not there. So, he was there. I thought he was there. Now, but you're here. And if you have a question about educational technology, technology, or anything regarding supporting our amazing teachers and students during this time of physical distancing, social collaboration, now let us know in the chat.
Hey, Brian.
Or by your microphone. Hey, Alex, there you are.
Question for Emma. I'm just curious, why not use Google Forms? Why use
Forms
them?
for? Oh, well, she wanted well, you could use Google Forms to do that, but she's wanting them to write long-form answers to a question in there. And that's,
Well, you can do it like...
Yeah, this is my first year teaching, and so all the curriculum is from the previous teacher, and so I'm
No, you're terrible. Oh, wait, that was me.
not the English teacher, history.
Oh, history, okay, good. Okay, then I'm off the hook.
And so,
Alright.
I'm redoing the curriculum, but I wanted to kind of weed out all the issues, and so this is the issue that I found all year, is that kids are just deleting the questions, and then when I go to edit or correct them in grade, like, I don't realize off the top of my head, like, oh wow, it's missing 3 questions because they're just not there. And so that's so I don't know if I want to continue doing that or switch to the Google Forms and have them just answer everything on Google Forms.
You could do the Google form. What I would do, how long are these answers that you're expecting for your students?
More answers, like a couple